In this episode, we'll be installing the brushless motor and ESC that I purchased for the mini-lathe upgrade. So let's get straight into it. Here's the test setup I have for my brushless lathe motor conversion. I have this 1500 watt power supply and the ESC and the motor. You can see the motor there, it's a 200 kV motor, and because this ESC doesn't have BEC installed, I'm just using a little separate BEC, and for now I'm using a radio controlled controller and receiver to control the speed, because I don't have one of those standalone speed controllers. So let's give it a go. Clearly seems to be applying some type of brake, which could be good, I guess. So I've already partially disassembled this lathe. You can see the motor there. It's rated at 4000 RPM, 200 watt class, so it's pretty powerless. Also notice this belt here, sort of very janky, to say the least. The original speed controller was on the front here, so this control panel goes here. You can see the original speed was maxed out at 2900 in high gearing. But yeah, there's something really not quite right with this as well. The speed control wasn't stable. When you would turn it up or down, sometimes it would slow or go faster, or yeah, so it wasn't very healthy. So the big challenge is to figure out how to mount the motor in here, the new motor, and come up with a way to connect either this existing belt or come up with some sort of new drive mechanism. So let's have a look at that. So I've gone through and disassembled it a bit. Firstly, removing this bracket off here and these two screws here, and then these two screws here. And so this lead screw and this carriage controller, or whatever you want to call it, comes off. That looks looking pretty filthy. And then here, just two screws to remove this back plate with this gear here. And then, you know, all we have left is basically the motor and the belt assembly. So hopefully we'll come up with a solution for that. And then hopefully these 4 screws here will get the motor off. So there we have it, the motor's out. And we can see the gear on the end there. Doesn't seem to have any movement, seems to be pretty well fixed on there. Just a simple plate here, pre-threaded holes on this plate. I might be able to reuse that. Don't know. Goes in there, and this belt here. The belt seems to be in pretty good condition, so I think I'm going to definitely try to reuse that. It'd be good if I could get some sort of tensioner on it or something to try and get rid of some of the movement. We'll see how that goes. So I've dug out this angle bracket which was kicking around, and that looks like it's going to fit in there quite nicely. So I think the idea would be to cut that off so it doesn't come out so far, obviously. Obviously that's coming out way too far. But we should be able to cut it so that it's basically similar dimensions to the old motor, see, and then mount that motor in there. Now these holes are pre-tapped, so it should be possible for me to come up with the pattern for that and tap these holes, and it should go straight in. So I think it's going to be pretty straightforward to fit it. And then we'll take a look at how we're going to manufacture or refit this. So I've measured all the holes and come up with some marking for the plate. See the plate here? So that's the face plate. I'm cutting the piece off there, and the center hole and the 4 mounting holes. You'll see instead of putting the hole here and here, I'm putting the 2 holes here so that we have some so the angle that the belt tension pulls on will pull on the 2 screws and not just on 1 screw. And on this side I have to try and tap these. I think I can get away with the M4 M5 size taps. I have to have a look what taps I've got available, and the end here I'll chop off. I made the plate as big as I can because on this side here I might try to put some sort of tensioner for the pulley mounted to the plate, and on this side here I'll probably try to, if we look at the size here, there's quite a lot of overhang even at the point I'm cutting off, and so hopefully I can mount some type of speed sensor and possibly a bracket for the ESC as well. So let's see how that goes. So I got it in there. Looks pretty good. I think I'll be able to mount the speed controller here at the left side. Couldn't quite move it as far forward as I wanted, but the belt looks like it will still be within the shaft, and I can extend the sprocket to sit a little bit beyond that in any case, so I think it's not a big problem. And yeah, my position was a little bit off, but I think there's plenty of adjustability. And actually I couldn't get it any farther forward than that anyway, because at the back there's a piece of the casting that actually sticks out and blocks it moving any further forward. So yeah, I think it's okay. I think it works out pretty good, right? So I just popped this gear off the original motor here. It's just held on by this screw, stop it from falling off the end, I guess. And there is a key which I've taken out. I've currently got it here. So after taking it off and trying it on this, I've also cut this down, by the way. Here you can see this actually fits straight on, which is just really lucky. And if we look at the key, you can see the key slot, and there's a flat on this shaft here. The key slot and the flat can line up. Now the key doesn't fit, so I'm just going to grind a little bit off the key, and then I'll put 2 grub screws on either side to further lock it to the shaft and stop it from having the movement inside, in and out, basically, right? So firstly, I've ground down the key a little bit so it wouldn't go in before. Probably ground it down a little bit too much, but I think it's okay. And then on both sides, on the key side and the opposite side of the key, I've drilled and tapped for a M3 grub screw. I put a shorter one here, a little bit longer one here. So that should go on. Maybe I tightened up that grub screw too much. Take a look here. Or I've created some sort of burr. Let's try again. There we go. And down in there you can see the flat spot. Key will now go inside the flat spot. And then the grub screw here, push on the key to keep it located. And on the other side here, just some additional support with the grub screw to stop it from moving laterally. in and out, and that should be it. It's really easy. Actually, I'm so surprised about how easy it is. So this motor is just something I found on Amazon. It's a Chinese input, no doubt, and I think it's meant for like scooters or kick scooters or something like that. But this is pretty much a direct fit, other than this L bracket, to go into this machine. So let me fit it and we'll take a look then. So I've got that on there. You can see here the key is in there, and I put a bit of Loctite, blue Loctite, on this side as well as on this side as well. And it looks like the belt is tracking pretty center. Doesn't seem to be going off the end or anything like that too badly. Well, a little bit. Maybe need a little bit more adjustment to stop it from doing that. Yeah, it's moving a little bit. I'll adjust that. The tension is pretty good, so I think I don't need a tensioner on it, which will be good. So I think I've got it running better now. You can see it's not coming off quite as much. The adjustment is pretty straightforward. I've just got this rather large adjustable wrench, and I can just put a bit of pressure on it, and then when it tracks right I can tighten and loosen these screws on the front here until it starts to track right. Anyway, I have to play with it a bit more, but it's not fully locked off yet, so it's still probably shifting a bit. Okay, so this is a front row seat. I haven't tested it yet. This will be the switch on, and we'll see how it tracks. Hopefully things won't explode, but you never know. Positive noises. Okay, actually I just noticed by twisting that there's some back tension, so maybe the motor is actually doing something there already. Ooh. So how's that tracking? It's not too bad. Still seems to push forward a little bit, right? Okay, so I moved the pinion out a bit. Try it again. Seems a lot better. You can see the belt is actually riding just inside the end of the pinion. Doesn't seem to get worse with any speed. So this is low speed. Pretty fast for low speed. The belt really rides out a long way out from that pinion. I'm not sure there's much I can do about that. This one's riding pretty good, right? Pretty scared to give it full beans when I have the covers on. Yeah. Oh, sounds perfect. Try and put a bit of load on it. Get some gloves under this. Tear a hole in my hand. Using it again. Oh, it's pretty powerful. Not as powerful as I thought it would be. Okay, so there you have it. So I think I failed to mention before, this is a 24 volt power supply, 1500 watts, but effectively we can only expect around about 50 to 60 amps peak, I think, out of it in this environment. So let's have a look at what sort of amperage we're getting here. So here we're seeing around about 3 amps. See if I can get this on here now. What I'll do is I'll put my hand here and I'll load it up, and we'll see how the amps change. So you can see if I load it right down, it's around about 6 amps. It doesn't stall out. I'm putting quite a lot of load on it. And the power goes up 6 amps. That's pretty good. So as you saw, thankfully the brushless motor fitted easily enough in and appears to be a promising solution. It's a big relief and a good start of the project. In the next episode I'll be working to complete the motor assembly, packaging the motor, ESC and sensors into a single removable block. I hope to see you then.